There are niche cases where you would actually need server-side rendering with your React front-end application. If you truly need that, you do have some options. Now, these days, the Vercel Next.js propaganda machine, oops, I misspoke there and had a Freudian slip. I meant to say the Vercel Next.js marketing machine. They would insist that Next.js was your only option. Well, in fact, you have multiple options if you are sure that you need server-side rendering with your React front-end application. There is Remix, which is very well thought out and supported. You have Preact, and if you enjoy the speed of Vite, you can configure Vite for server-side rendering. Again, please do your due diligence to research if you truly need server-side rendering of your React application. I hear a lot of hoopla that states that, well, I use Next.js even though I don't need server-side rendering, but I enjoy the ergonomics of Next.js. Well, you can set up your React application to have excellent developer ergonomics without server-side rendering, without Next.js. So, with that caveat out of the way, if you want to try out server-side rendering with React.js front-end application using Vite, I will show you how to do that in this video and quickly explain what is all involved step by step. Vite does provide you with documentation on how to set up server-side rendering. It is very basic. And as you can see here on the right, we have the table of content. If we were to go to the example projects, as you can see here, is very generalized instruction for different technology, front-end technology, including React and Preact. If you were to click on the React example project, it'll take you to this GitHub repo with a very basic React SSR setup. And if you keep on scrolling down, it'll talk more about the setup, but it's very generalized. I can do better for you. Okay, I can take you through step by step and explain what uh, the setup means. And so we will be setting up this example project so we can learn how to set up Vite React with server-side rendering. We'll also be incorporating the React Router version 6. Some of you might refer to as a router, depending on what side of the pond you're from. But as you can see here, we have three different routes. It's all server-side render, and we can navigate just like a normal SPA single-page app. There's no page refresh, as you can see there. All right, stay tuned. Setting up server-side rendering with Vite and React is similar to how you would set up Vite with React for a front-end application. There are multiple approaches. You can certainly use the command line interface and then um, extend that's set up with whatever you need, or you can just roll up your own. In this case, I'm going to go with the default CLI. We're going to issue the command npm create vite at latest. We'll give it a name. We'll call it Vite SSR demo. Yes, I want that package. So here, we are going to use the cursor key to go down to others, enter. We want the create Vite extra option, package name. Let's keep it default. And we are going to select SSR React, um, non-streaming. And then we are going to select TypeScript with the Swift compiler for faster compilation. And their normal routine, we're going to go into Vite SSR demo. We're going to run npm I, and once it's installed, you want to go ahead and do a run dev. You can do that off screen. You can do npm run dev to make sure everything is installed correctly. I'll see you in a bit. I wanted to walk you through the command line interface installation process to show you what it's like and how simple it is. And then I also wanted to show you what the CLI generated for you in terms of scaffolding the code. In actuality, I've took the liberty of creating a starter um, project for you to download from my GitHub page. I will have the link in the description. I also have a completed application on the main branch, and then the starter branch will be your starter project, and you can install this and clone this. Because the objective of this video is to talk about setting up server-side rendering with Vite and React, not for you to type a bunch of code that is not related to server-side rendering. This is the starter project that I've provided for you from my GitHub. It is essentially a skeleton application. It's the same application that I show you at the beginning of the video. So we will be using the skeleton app to build out server-side rendering with Vite and React. There are 3 files that the Vite command line interface gives us that you don't normally see with a client-side application. Of course, these 3 files are related to server-side rendering. And the files are the entry-client, entry-server, and server.js that lives outside of the source directory. I will be going through every one of these files and explain to you what they're for. But first, let's have a look at the package.json file, because it is uniquely server-side rendering, unlike client-side app. Starting on line number 7, the dev command actually invokes a Node.js server runtime. It is an SSR app after all. Number 8, the build command is a combination of line 9 and 10. So let's go to line number 9, the client-side build. It is invoking the SSR manifest flag, and I will explain what the SSR manifest does and how it's generated inside of the server.js file. And of course, it will build and then create a distribution uh, directory in our app for the client side, and then the same thing for the server side. Um, and of course, it will do the same thing as above, and it will place a server.js file inside of our distribution for use on the server static assets. So on line 15, we can see that the Vite SSR command line interface install the Express Node.js library for us. Now, if you are a seasoned um, JavaScript or TypeScript server-side developer using Node.js, then you are very well um, versed as to what the Express library does. However, I'm making this video for a wide audience. Now, if you're strictly a front-end developer, you might not be familiar with Express. So Exp the ExpressJS library for Node, specifically for Node.js, is a library that helps you to build server-side API quickly and with less code. The library itself abstract a lot of the work for you. It is similar to what Spring Boot is to Java, or Flask, or Django is to Python or Python. Um, so it's like that. And the reason why the CLI install Express is because obviously being a server-side rendering application, we need a server-side technology, right? And so the CLI is using Express to generate this server.js file for us. And I will go into this in a more detail a little bit later. But so that's why the Express library is installed as a dependency. And then lastly, serve. So this serve package, npm package, is just used to serve up static resources from the server. First, let's look at the entry client file. The first thing I want to point out is that on line 2 and 3, we are only importing core React library, starting with React library itself and React DOM, just like we do in normal client-side React applications. But on line 3, we are actually specifically importing the client part of the React DOM library. So uh, let me explain what this file does. So at a high level, this file is responsible for converting static HTML into dynamic content by attaching event listeners, event handlers to the HTML elements. This is in computer science known as hydrating. Is usually referred to, usually used in the context of server-side running application, but it's actually a computer science term. So hydrating, uh, so thereby enabling client-side interactivity by end users initially and as they maneuver through the application itself. On line 10, if you notice that we are uh, we're calling the hydrate root method, static method from React DOM. And we are calling hydrate root method from React DOM again to actually attach the actual event handlers to the static HTML content. Again, it will hydrate initially, and then it will rehydrate each server render HTML element and content to make it interactive as the end user interact with the app um, throughout the life of throughout the cycle of life as they uh, as end user use the app however they please. And the reason I pointed it out that these two core libraries is that server-side rendering actually existed um, in React for quite some time. I want to say starting with React 16.8, but certainly with 17. At the time of this recording, we are up to React 18.31, and React 19 is around the corner already. Now for the entry server file. So on line 2, we are just importing the core React library, and then on line 3, we are importing the React DOM server from React DOM server as opposed to the client in the client file. So this file uses the React DOM server imported here, of course, to render the application on the server side. Why? Well, this is potentially useful for search engine optimization purposes because it allows search engines bots to crawl the application and index its content, thereby potentially ranking the application and certain keywords higher for better marketing and utilization purposes. Also, potentially, this can also boost performance because it allows the application to render faster on the client side. Now, directing your attention to this render to string static method from React server. So the render to string method is used to convert all of the React components in the app to an HTML string, which can then be sent to the client for initial rendering and continuous rendering as the end user navigate about the application. Finally, let's have a look at the server.js file. Now, right off the bat, I will tell you that this file was completely generated by the Vite command line interface, including the comments. The only comments that I have added are on line number 1 and 2. Now, this file is used to set up a Node.js Express server to handle server-side rendering for our React application. It dynamically selects the appropriate server-side render function and template based on the environment, whether it's development or production, and serves the render HTML to the client upon request. The server is set up to serve client-side assets in production, but uses Vite middleware in local development. The server also reads the SSR manifest file in production to determine the appropriate render function to use. Now I will explain a little bit more about SSR manifest here in a moment. So I've mentioned SSR manifest several times. The SSR manifest contains mappings of module IDs to their associated JavaScript chunks and asset files. When I say chunks, I mean CH and KS, chunks of codes. And this is used to determine the appropriate chunks to preload for each page and to determine the appropriate render function in here to use for server-side rendering. The SSR manifest is generated from the client bill on line 9 because we want to map module IDs to client files. Now, in production, we need to read and pass the manifest to the render function. This allows the render function to determine the appropriate chunks to preload for each page based on the manifest to increase speed. Now, if you work with Remix or with Next.js, this principle is also used in those frameworks and libraries as well. Now let's take a look at the folder structure itself in the project. So inside of the source directory, I have the component folder, and inside component, I have the layout folder, and in that I have just a basic navigation bar. And of course, I am using React router version 6. So we have these dynamic links. Just a basic navigation bar. which is being pulled into a very basic React component in TypeScript. This is just very basic React, so I won't belabor the point too much. Um, and then I am exporting in the index.ts file. Now you do not have to set up your project this way, but I'm setting up the folder structure this way because if you decide to use my starter project as a template for your application, you can scale up. If you scale up your React application, this approach is a little bit easier to manage and it gives you better ergonomics. And typically, this is how it's set up using something like Next.js, which is very popular. Next is the pages directory. So pages are components that it's routed about using the router. So you can think of it as like views. And in fact, in some Next.js application, the pages directory is referred to as views. But again, pages are just components that has a React router component to it. The React router views to it. And we have three views here, and that's about, contact us, that's just very basic React stuff. And then of course home, the home root is the default root. And again, I'm setting up this project for scaling purposes for if you want to scale up. So I'm exporting it using the index file. And we will be using React Router version 6, and I'll help you set it up here shortly. If you are using my starter template, then you would have already installed React Router DOM. If you're not, then please install React Router DOM now. By the way, as of the time of this recording, which is in the middle of September of 2024, these packages are the latest version of each node packages. The router is always the star of any single page app library or framework because it routes the views through a single DOM element. There are certain challenges when it comes to routing in a server-side rendering application. We obviously cannot use BrowserRouter on their server side because it's a pre-rendered application, so it wouldn't work. Therefore, we need to import a static router, which coincidentally React Router DOM has. And for the client side, we can use the browser router. Let's start with setting up the router file. So let's go ahead and import root and roots, singular and plural, from React Router DOM. And then we are going to import the views. And I have three of them: home, about, and contact us. And let's go ahead and import about, contact us, and home. It's contact us because I'm actually exporting the contact us. And then we want to create the router itself as JSX. We're going to return the roots, and within roots, we are going to have individual routes. And then the index route is called home. And then the about, of course, is going to be about. And finally, contact us. Please don't forget to add the index to the home root to make it the default route. In the entry client, we are going to import the browser router from React router DOM, and then we're going to import the router which we just created here into here, of course, and then we're going to use composition. We're going to compose inside of the main React component here. We are going to call the browser router, and then we are going to compose the router that we created inside of it. And that's it for the entry client file. In the entry server file, we are going to import the static router from React DOM, React router DOM server. Again, we cannot use the browser router in here, we have to use a static router. And then we're going to import the router that we created in here. The static routers require a location prop. And then within that props, we need to supply a value called path, a string value. So what I'm going to do is I'm going to create an interface called iRenderProps. And within that interface, we are going to contractually have a path, which is a string type. Now you can use a type if you wanted to, but here I'm just using an interface. And this is how we are going to use that interface. We are going to call path here, which will have a type of iRenderProp. Okay, and then we are going to do some composition here. Static router, location, path, and then we are going to pass our router file in here. And that is it for the entry server. At this point, we are ready to run our app. Now going back to the package.json file, we can run npm run dev. Now we do not have to build to run the app locally. We can just issue the command npm run dev, and then go to the browser and play around with our application. If you were to view page source in Chrome, this is what you would get. If you want to debug the app, you would have to use the inspector to see the individual DOM elements. Now, if you were to run npm run build, it will build and generate the distribution directory for us, and we'll have a client and server folders in there. And then from there, you can run npm run preview. Okay, and then you can go to the browser. Same thing as before. You use the inspector to inspect the individual DOM elements. But we are not quite done yet. If we do an npm run dev again and go to the browser, we can play around with this and see that it's working as expected in the browser. But if we go to the console and we do a refresh, you're going to see some warnings and errors that look something like this. Warnings like this and errors like those. So these type of warnings and errors happens on pretty much every single server-side rendering libraries and framework out there, including Remix, React, and most definitely Next.js. You see this a lot in Next.js, and I'm going to show you how to fix this. The reason that this is happening when I refresh the application is because the server needs the HTML that's generated on the client to be an exact match. So in other words, the HTML that is on the server and on the client needs to be an exact match. The server is expecting the HTML to be an exact match. So when I refresh this to rehydrate the application, it doesn't see an exact match, so it's throwing these errors. The fix for this is quite simple. So go ahead and import useState and useEffect from the core React library. And within your functional component, within the function, create a slice of state called hydrated and set hydrated, or whatever makes sense to use. But this is the normal convention. Let me explain why we're using the two hooks here so that we are perfectly clear. So the purpose of the use effect is to ensure that the app is fully hydrated. This is necessary because the server-side rendering process can cause errors if the app is not hydrated before rendering. The first render is what the server uses to generate the HTML file, and is also what the client-side app will use for the hydration process. During this first run, hydrated will have the default value of false, which will cause the component to return null. Also in this first run, use effect will call set hydrated true, which will trigger a second render after the first has completed. By the time the second render runs, the app will already be hydrated. So there's no need to worry about the errors occurring anymore. At this point, hydrated will be true. If you've worked with Next.js 12 or 13 in the past, you might have run into this problem before. Now let's go back to the app and retest. So normal routine's working as normal. Now let's try to refresh. Okay, we're not getting that error anymore. This concludes my tutorial on server-side rendering with Vite, React, and TypeScript. Thank you for watching. If you are not yet a subscriber, please consider subscribing. If you are already a subscriber, welcome back. I appreciate a thumbs up on this video. Thank you. See you next time.